Very good morning, students. I am Dr. K. Rajesh, working as an associate professor in the Department of Physics at Amit University. I have been working here in Amit University for the past 8 years. Very happy to welcome you for today's class. Last class we have discussed about different kind of conducting materials. The continuation of the last class, we are going to see this specialized topic, semiconductors today. What you have seen in front of you on the screen is the different kind of semiconducting elements. And so one by one, if you try to name it. What is this? Yeah, it's a microprocessor. Very good. What is this? Just guess it. Yeah, very good. It is LED. Next one. Check this. What is this? Transistors. And what is that last one? Yes, good. That is capacitors. So these are the elements, electrical and electronic devices that is going to be used in many electrical circuits completely based on the semiconductor material. You can see three different material on it. The first one we have a metal piece and wood and a glass. As you know, wood in the last classes we have said that wood is a insulating material. That means it won't conduct any electricity through it. Look at this bulb. When the wood is connected to the circuit, the bulb is not going to be glowed. That means it doesn't conduct. We have an electrical circuit. In between the electrical circuit, we have put a piece of wood. So it restricts the flow of current. The next one, we have a metal piece. Okay, we have used two different metals. Steel I have used it and non-metal used. Metal, as you know, it is a conducting material. It is allow the electrons to pass through it. When you connect this metal piece in between two electrical wires, the light is glowed. That means it conducts, right? So what would be semiconducting material? Whether it is an insulating material or a conducting material. It is a different, it is not completely insulating material or it is not completely a conducting material. It acts as an insulator and it acts as a conductor based on the temperature. That's what we can consider as a semiconducting material. Look at this range of conductiveness. See, this conductors have a very huge amount of conductiveness. It's the order of 10 to the power of positive. Look at this left side on you, it is negative, 10 to the power of negative. That is conductors is very low. You can see the germanium and silicon over there. We have put it as a semiconductor. It ranges from 0.5 to 10 to the power of -4 ohm. So this is what the conductive range of the semiconducting material. Then we have classified what is semiconductors and all. As I mentioned you, the conductivity of semiconductors lies between a perfect insulator and a perfect conductor. This is one type of classification. Other type of classification is with respect to the resistivity. As you all know that when the temperature increases, what happens? The resistivity is going to be increases. In the case of semiconducting material, when the temperature increases, what happens? The resistivity is going to be decreases. If the resistivity decreases, what happens? Yes, conductivity is going to be increases. Look at the graph. So when the temperature increases, the resistance is going to be decreases. That means the conductivity is going to be increases. It was founded in 1833. Then we are going to classify what is semiconductors materials and all. Okay, we have two different kind of semiconductors materials. Okay, based on the composition of that. Okay, before going into that, I just wanted to show some graph on it. Look at this table. We have classified the temperature of metals and semiconducting materials based on the temperature, how the resistivity is going to be changed. For 0 degree temperature, copper shows 31 ohm, germanium shows 5.2 ohm. That means copper is having high conductivity, germanium is having low conductivity. When the temperature increases at 100 degrees centigrade, look at this resistivity of germanium, it is 0.029 ohm. That means the conductivity is very high, resistivity very low. Okay, and all these conductors, semiconductors and insulators depends on the band gap between the valence and conduction band. Last classes we have seen what is valence band and conduction. Valence band is almost fully occupied band, that most of the electrons are almost in the valence band. Okay, conduction band partially full or it can be empty. Okay, when energy is given, valence band will start to push this electron to the conduction band and it reaches the conduction band. Reaching this electron to the conduction band determine whether this material is a conductor or insulator or semiconductor. Okay, the gap between the valence and conduction band will determine the type of materials. Okay, look at this. The red one is conduction band. The blue one is valence band. The gap in between that we call this forbidden energy gap or normally called as energy gap. Okay, As we know that in conducting material, the band gap energy will be forbidden or it will be almost overlapped. Conduction band and valence band is almost overlapped. Look at this picture. I just give an example. We have a road that. Look at this center median. Okay, on your left side there will be less number of vehicles. On your right side will be large number of vehicles. The large number of vehicles will be shown as an example of valence band. Number of electrons almost filled or it is high. Okay, on the left side that will be called as a conduction band. It's partially filled or empty. Then between these two lanes we have a linear thing, right? We call it center median. The breadth of the center median will determine whether the car can go to the other side or not. If the band is very high, what happens? The car won't go to the other side. If there is no band, there is no gap into that, car easily go to the other side. That is what we get. If there is no gap into that or a very minute gap, cars can easily go into that other side. That will be called as conducting material. If the gap is very high, that will be insulating material. If it is a nominal gap, okay, then we call it as semiconducting materials. So next we can see this what is a band gap structure of insulating material. In insulating material, the gap is very high. This electron cannot move to the excited state or what we call as conduction state. Look at the next one is your semiconductor. The gap is very moderate. So insufficient of incident energy makes the electron to transition to the conduction band. Okay. Here normally this external energy will be heat because semiconducting material, when it is focused to a heat energy, the electrons are excited, it goes to the conduction band. At normal temperature, it acts as an insulating material. When the temperature increases, it acts as a conducting material. So we don't have a separate insulating material, separate conducting material for semiconducting. Same material can act as an insulator, can act as a conducting material, depends on the temperature. When the temperature increases, resistivity drops, conductivity increases. This is what the concept. Look at this diagram of all the three concepts. Your conductor, insulator and semiconductor. First one is overlap, no gap between that, electron easily moves. Second one is semiconductor, moderate gap, when sufficient energy is given, it goes to the excited state, conduction. Third one is insulator. Okay, and this is what the introduction about the semiconductor material. Semiconductors can classify into two different major categories. The first one is composition. Based on the composition, how many materials are there, we can classify into two different categories. If a semiconducting material is made only one element, then we call it as single or elemental semiconductor. That means it made by only one element, no other composition in that. That is elemental semiconductor. Example, we can give it germanium or silicon. If more than one semiconducting material is combined together, it forms as a semiconducting material that will be called as compound semiconductor. This is one type of classification based on the composition. Second type of classification is what we have seen in the previous slide. That is what is that? Extrinsic semiconductor and intrinsic semiconductor. Intrinsic semiconductor is nothing but pure form of semiconductor. We have germanium and silicon. Germanium is having 32 electrons and whereas silicon is having 14 electrons. The outermost orbit, this valent electrons for these two materials are 4. So they call this tetravalent material. Okay, they call this tetravalent material. That means 4 electrons in the outermost orbit. If these two material alone will form a semiconductor, that will be called as intrinsic semiconductor. Extremely pure semiconductors are intrinsic semiconductor. When we want to increase the conductivity of a semiconductor, we need to add some more material into that. For example, you cannot make a pure gold into an ornament because pure gold is very ductile nature. So we have to add some copper into that. So it is gaining that hardness. Likewise, if you want to increase the conductivity of a semiconducting material, we need to add some material into that. The process of adding this impurity into that is doping. Okay, then that material will be called as dopant. Based on the composition material or based on the impurity atom, we can divide semiconducting material into extrinsic semiconductor, that is P-type semiconductor and N-type semiconductor. First, let us go to look at this diagram. This middle one is different in color and this process is called as what is that? Doping. Okay, other colors are red, that will be either germanium or silicon. The middle one is an orange color, it may be a doping agent. Okay, so N-type semiconductor means a pure semiconductor we have taken tetravalent atom and we have a pentavalent impurity. That means 5 valence electrons. Okay, that outermost orbital they may have 5 valence electrons. If these two combine, example germanium, can we just take a germanium and arsenic. These two are going to be combined and form a semiconductor. Germanium has 4 electrons, valence electron. Arsenic has 5. So what happens? 4 electrons of arsenic and germanium will combine and go to the conduction. 1 electron remains in the middle. Okay. So number of electrons is more than the number of holes in the conduction band. Then it comes to a n-type semiconductor. How to remember this? N means negative. That means this kind of semiconductor will have large number of negative atoms compared to the positive holes. This is what we call as n-type semiconductor. Look at this GIF images. We can see that combination of arsenic and germanium. So if you look at this, the 4 germanium atoms around germanium is going to be combined with this arsenic. Arsenic have 4. 4 is going to be joined with germanium and arsenic, and 1 is in the middle. Okay, so one negative electrons is higher than the holes, so it will be called as n-type semiconductor. Next, we are going to see this p-type semiconductor. Boron is going to be the doping agent here. Okay, we have 4 valence electrons germanium and 3 valence electrons of boron are going to be combined. So what happened is 3 of this germanium and 3 of this boron is going to be combined. 1 will be remain, but this electron is going to be start from the valence and it won't reach the conduction band. So the number of holes is more than the number of electrons in the band structure. Okay, we have 4 holes, but we have 3 electrons. So majority of positive holes is here. So this type of semiconductor will be called as p-type semiconductor. Okay, I hope that you have understand. Tetravalent and pentavalent are combined. They are going to be joined as n-type semiconductor. 4 plus 5 n-type semiconductor. Tetravalent and trivalent is going to be formed as p-type semiconductor. Understand? Okay. Then we have these 2 different categories, p-type and n-type. These 2 are going to be joined because in the first slide I have shown some electronic parts that are made by semiconductors. Right? How these are made? The main application of semiconductors diodes. Okay, we have used diode in almost all the electrical and electronic circuits. How diodes are constructed and how it is going to be working. Okay, I told you how p-type semiconductors form, how n-type semiconductors are formed. When you able to join these 2 semiconductors, that is p-type and n-type semiconductor, we can able to make a diode. Diode is nothing but the combination of p-type and n-type semiconductor. Whereas the red color in this diagram is which have a majority of holes, that is positive, and over here the green color it is negative type semiconductor. When these 2 join, we can have a diode. Okay, we have formed a diode. How it is going to be working? A diode should be works only in a forward bias. As you all know that what is forward bias? When you connected a positive terminal of a battery to a positive type of semiconductor and negative terminal to the n-type semiconductor, we call it as a forward bias. When you connect it to forward bias, holes and electrons are able to crash over the junction. What is the junction? The 2 region, the positive and negative type semiconductor is going to be made. That is region we call it junction. Okay. When you connect it to forward bias, positive holes in the p-type semiconductor are able to crash over the junction and negative charges in the n-type semiconductor crash over the junction. So near the junction, we have mixed of polarity. We have positive type material and negative type electrons over there. So they get cancelled each other. So near the junction, we have a region, small region, which doesn't have any movement of particles. We don't have holes, we don't have electrons because they get cancelled each other. We call it as depletion region, or simply we can say no movement region, because most of the part of the p-type will have a holes that will be moved and n-type will have electrons. But this region near to the junction, we have a depletion region without any movement region. Okay, this is the reason where this production of current will be produced. Right? Look at this GIF image. You can see this. The blue one is your positive negative electrons, and the red holes are going to be, when it is powered by, is going to be crash over the areas and will form the electrons. Right? In the beginning of the class, I told you, I showed some things. Right? What is the use of this semiconducting material? We have used conductors, conventionally. Okay, a lot, as you know, that the first computers are almost very big that it will be contained to your physics lab. Okay, but nowadays we have a chips, we have a small gadgets in your hand that can cover everything. Okay, that is possible only because of the semiconductor industries. Okay, we have a Silicon Valley. Which is the Silicon Valley of India? Oh, good. We call Bangalore the Silicon Valley. Okay, we have a Silicon Valley in USA, right? So this industries in the Bangalore and USA will completely depends on the semiconducting material. All your microprocessor, transistor, capacitors, everything made by semiconducting material. Nowadays, the type and shape of the material is going to be very, very, very small. That makes this, what is that, larger material into small things. Notice that your gadgets are very small. Okay, the technology has improved. It reduces your cost, reduces your places and everything. Okay, so semiconductor material is going to be ruled for this 21st century. There is no doubt on it. Okay, so I believe that this class is going to be very useful to you. And thank you.